Could you please open it? Wow. It's okay if I start an interview?
Sure, go ahead.
Thank you so much. So first of all, could you please introduce yourself to Japanese people?
Sure. My name is Benjamin List. I'm a professor at Hokkaido University, foremost and importantly. I'm also a Max Planck director here in Germany, and I have an affiliation at the University of Cologne. And I'm a chemist, and I have focused during my studies on organic chemistry, and then moved more and more into catalysis. And we have developed a new type of catalysis that's called asymmetric organocatalysis. And just this year, I have received the Nobel Prize in chemistry.
Could you please tell us again about the background and the meaning of this year's Nobel Prize in chemistry?
I'll be happy to. So what you need to know is that catalysis is really a beautiful science, because in catalysis, you need just a small amount of a substance that engages in a chemical reaction, but it doesn't appear on the side of the starting material, and it doesn't appear on the side of the product. So it just operates and facilitates a chemical process, but it is not being used up in it. And that is so immensely powerful, because you have this, what is called turnover. The catalyst can repeat its action numerous times. And that's why chemists are so in love with catalysis. But there's an additional aspect that many people don't know, and that is catalysis is also an extremely important technology. And so, like, for example, in the last 100 years, we would make gasoline, we would make plastic, we would make ammonia, in essence, all chemicals. And out of all chemicals, we make all medicines, right? So pretty much everything that surrounds us ultimately had been in contact with catalysts at one point. Now, the mysterious thing about this is that for literally 100 years, from the beginning, from the early days of the science of catalysis in 1909, when Wilhelm Ostwald won the Nobel Prize for the physical basis of catalysis, until the end of that century, chemists were convinced that you need metals in the chemical catalysts. Of course, enzymes is a different story, but in the chemical catalysts, we thought you would always require metals, transition metal catalysts. And we found that, in fact, this is not true. We can use small organic molecules, and those catalyze, like enzymes, with high selectivity important chemical reactions. And that was the basis of the Nobel Prize.
Germany is famous for chemistry, especially catalysts like Haber-Bosch.
Yes.
The background of Germany affect you?
I don't think so. I mean, this is not really present when you engage in thinking about your own scientific choices, right? Like, what am I going to do in my independent career? What is it? What attracts me? What am I fascinated with? I don't think you feel all the history on your shoulders, and certainly not a national history, right? As you know, we are scientists. We're not kind of local, right? Science is by definition something sort of non-localized. Everybody understands the results of science. They're reproducible by definition all over the world. The experiments I do here, you can do in Hokkaido, no problem, right? That's the beauty of science. And I never felt like I'm in a particularly German tradition, I have to say. So I have to say, when the call came on October 6th, this was a very, very beautiful event. And I will never forget that moment, of course. It's like the ultimate fulfillment of a scientist's dream, if you think about it, right? I mean, I have to also say that I'm not in the world of science to receive recognition. And I would not recommend this to anybody, because, I don't know, you might get the recognition or you may not get it, but it doesn't make you happy, I would say. But nonetheless, the call made me really happy. And of course, to get this award is the ultimate achievement of my career. Now, the event took not place in Stockholm, unfortunately. This was a bit sad, I have to say. But I also said it at the event 2 days ago. It was in Berlin, and it was a nice event. You know, many great people were there. Our president from the Max Planck Society, high-level politicians, great scientists. The other Nobel laureate from physics was there, Professor Hasselmann, and the families were there. And it was a given the circumstances, a beautiful event. And I said it already then, and that is first of all, I would not complain to not be in Stockholm, right? I got the Nobel Prize. This is just one day, right? But the Nobel Prize will remain forever. It's like for infinity, for eternity, this Nobel Prize will remain. And that's so in that light, of course, you cannot realistically complain. Nonetheless, I would have loved to be in Stockholm, and I look forward to going there next year, perhaps to have another celebratory event.
Thank you so much. So I saw your wife in the live streaming. So can I ask your family?
I have a couple of boys. They were both with me. My wife was there too. Also, my two brothers were there. My mom was there, a cousin, and my auntie. She also won a Nobel Prize in 1995. She was also there. So you see my two boys right here when they were little. I was very happy to have them with me. I love them, and they are so enjoy. We share this joy in the whole family. It was really beautiful to see that.
Thank you so much. So next question. So what were you like in your young age?
Oh, that's an interesting question. So when I was a teen or even before, as a child, I was a wild boy and I was very free. It's a very different style of education system that was popular in Germany at the time. And it wasn't widely popular, but it was the education system my mom was sort of believing into. And that gave me the ultimate freedom. So I know this is unthinkable in Japan. It's a very different style. And as I said, very few people were like this, but my mom, I could pretty much do whatever I wanted to. And when I was 11 years old, I somehow wanted to become a chemist, even though I haven't had it in school. And so we built a little laboratory in the cellar of a friend, and we could purchase all chemicals. I was just 12 years old. And we had sulfuric acid, we made gunpowder, and it was a pretty wild experience. And I'm very, now in hindsight, I'm very grateful for it, even though my own kids are not educated like this. And I'm not sure if by luck I came out relatively well, or, with this kind of training, I don't know.
So thank you for sharing your precious memory. So what made you interested in chemistry?
For me, I was very naive and very young. I mean, I was 11 years old. And somehow I had philosophical questions. What is the world made out? What are humans created from? And what determines their actions? And I thought, if I understand the molecules, how molecules interact, I will be enlightened. I will know everything. I really thought that. And then I started to study chemistry. I found an very old book. Maybe it was already, 60 years old when I found it. And, I got into it so deeply that when I realized chemistry does not deliver the answers to my questions, it was too late. I already fell in love with chemistry. And then these questions were put aside for a while. So yeah, that's how I became attracted to chemistry.
Thank you so much. What about ICReDD? So I would like to know what you are excited and what you want to achieve in ICReDD.
So I have to say, chemistry, in contrast to large parts of physics, is not really, I mean, especially this is especially true in chemical synthesis and catalysis. It's not a predictable science, right? So this is very different. Like people have predicted black holes and neutron stars, and so many things in physics can be predicted. But the actions of molecules, because they are by definition multi-body problems, they're really, really complicated. And while we have the equations, the Schrödinger equation, it's right there, we cannot solve this in its complexity. It's impossible. We can only approach solutions, but we can never fully solve it. And given this, it's kind of like there's a lot of trial and error, and there's also a lot of intuition in chemistry. It's somehow a magic component that nobody really understands. But I find it fascinating to question, will we one day be able to use artificial intelligence and machine learning combined with very high-level quantum mechanical calculations and experiments to design and predict chemistry? I mean, I find this fascinating. Of course, it could ultimately, maybe the goal of ICReD, maybe ultimately this will replace us. Maybe I will have no job anymore because we have powerful computers and robots that do the work for us. But in contrast to others, I'm not afraid of such a scenario, because then I will be free to think about other problems and to do other things, enjoy the world and life in other areas than chemical synthesis and catalysis. And I'm sure there will be enough space for human intelligence and creativity. So that's why I'm in ICReD, and that's why I enjoy this so much. And yeah, let's see how this will go. I mean, if the beauty of this is, if we lose and it turns out after 10 years, we are not able to do this and we still need our human minds, great, no complaint. On the other hand, if we win, and we find computers and robots that will solve all these issues, we also win. So, we cannot lose. That's why I love to be in ICReD.
Thank you for your great comments. So the ICReD staff beside me are so happy. Yeah. Thank you so much. Dr. Tsuji really helped not only us, but also media in Japan a lot. So, and he told us about you a lot. So tell us about Dr. Tsuji.
So what I love about him is, well, first of all, he was my first Japanese graduate student. And I have always admired Japanese chemists. Like there is this long tradition of outstanding creativity in this country. Like there's so many amazing chemical synthesis and catalysis people in Japan. I mean, it's unbelievable. And he comes from that tradition in Kyoto University. And it was just a pleasure to have somebody like him, and to see how Nobu has developed into a cosmopolitan chemist also, right? That's an aspect I really love to see with all the people that come to my group, right? We are in Germany, yes, right? But there are people coming from the United States, from Japan, from China, from India, from all over Europe, and we're kind of a mixing a pool, so to say. Everybody mixes up and we learn from each other. And Nobu is now a cosmopolitan. He understands our culture, and he is also very much at home with the Japanese culture, right? And that's a strength, right? I'm not speaking about chemistry at this point. I'm just speaking about sort of cultural things. And it's really important, I would say, that you understand the different cultures. For example, in Germany, it is very common that graduate students would criticize me in the seminar, in our meetings. So there are 30 people there, and a graduate student will say to me, no, I don't think you're right, Ben. And this is totally acceptable, right? In Japan, I guess it's maybe a new style, I would say, but it's also coming in. I know the Japanese, you're not like in the last century, of course, but there are slight differences in terms of culture. And he learned this and he accepted this, both that he can criticize me and that I criticize my students sometimes openly. And also then he worked on a challenge that I felt was like one of the holy grails of organocatalysis, right? Can we at some point also activate olefins? Olefin activation is synonymous with transition metal catalysis, right? Transition metals we know can do this, but can we also use simple organic molecules? And that was a grand challenge in my group, and he nailed it. I mean, there's no denying he solved that problem. And that takes a lot of perseverance and some determination and hard work and creativity. And so I'm very, very proud of him. But now seeing him, how he develops at ICReD, I hope he's not listening. I don't want to make him flush, but I have to say I'm very proud how he creates his own style of science now. You know, that's really nice to see. You know, it's not like Me Too science, and it's not like Ben List science. It's developing into his own style, and that's really, really, really great to see.
Thank you. So we are really looking forward Dr. Tsuji's paper. Thank you. By the way, I would like to know the expression you use in the ceremony. Nobel Prize is beyond time and space, you said. So what does it mean?
Well, I mean, this was, first of all, it was in the context of being in Berlin on the 7th of December, right? So there's time and space, rather than in Stockholm on the 10th of December. There's again time and space. And I was speaking about this. I'm a bit sad that I'm not at another time and another space, basically, right? Another location. But the Nobel Prize is not limited. That's what I said before. It's like science itself, right? It's like, it's not limited to a certain location. It would be silly to say it's limited. Like, I mean, I don't want to compare myself with these heroes of science, but do you think Einstein's discoveries are limited to Berlin or Switzerland, or where he had the idea? Of course not, right? They pervade the entire universe in a nutshell, in an essence, right? So in that sense, the Nobel Prize, I said, points towards infinity and eternity, right? Of course, it is not. It's limited by itself. The Nobel Prize is also just one event in time and space, but it points towards these ultimate realities. Yeah, it's hard to explain.
Thank you. This is my last question. So beyond time and space, please give your message to Japanese, especially to young Japanese.
Yeah. So don't make scientific recognition awards or prizes your goal, right? This will not make you happy. And that's of course a problem, right? You want to be, we all want to be happy. I mean, that's what all of us want. But then we sometimes make mistakes in the decisions of what we do, what we pursue. We forget that what we should be pursuing is our happiness. And then we pursue something maybe that our parents told us to pursue. Like, for example, if you feel like you're an artist and you want to be a ballet dancer, right? And this is where your heart is, and where you really feel at one with the rest of the universe. This is where your enthusiasm lies. Then do it. Even if your parents tell you, no, you should work in a bank. You make much more money. It's much more secure. You can support a family. Don't do it. And because the bottom line is you may or may not reach full recognition as a ballet dancer, right? Maybe you will not be the most famous star in Moscow. I don't know. But at least you pursue your happiness, and what you do, you love, right? So whatever comes out of this is not important anymore. And vice versa, if you're now forced into becoming a banker and you say, okay, maybe I will make more money. Maybe you will make money or maybe not, but you don't do what you love, right? And then imagine you're not reaching the ultimate goal, then you have done what you haven't loved and you haven't even reached the goal, right? So in that sense, I think we all have something deep inside us that wants to be revealed. It's kind of our deep passion, and we should follow that. We should follow our enthusiasm and do what we're really good at. Like, I know the young generation, they want to play computer games, right? And some are really good at computer games. And I would not even advise against that. I mean, it's kind of silly waste of time from my perspective. But if you're really, really, really passionate about it, why not even doing this? You can do it professionally, or you can invent your own video games or do stuff like this. Yes, even if your parents and myself would advise against it, I mean, pursue your own passion. That's what my advice is. And if you're lucky, like me, you're in the world of science. And that is, I would say, the greatest gift, because we work with new things that have never been in the universe. And if you make catalysts, that's particularly beautiful, because catalysts in themselves have this magic that you never know what they can do. Maybe they solve a big problem. Maybe they convert CO2 into diamond and oxygen, right? This imagination is always there. And that's why science, I can recommend going into science, but again, only if you really are passionate about it. If you feel like there is enthusiasm inside that can support such a career.
Thank you for your great message, Dr.List. So thank you so much. So we really appreciate you for sparing your precious time today.
By the way, I was hearing your message. Thank you very much.